Assalamu alaikum student. Today we discuss the topic that is the diffraction of X-rays by crystal. We know that X-ray is an electromagnetic wave which has wavelength is 10 to the power minus 10 meter. When this X-ray wave is incident on an atomic electron, here we take the atomic structure. When this ray is incident on the atomic electron, it is observed by this electron and vibrate the electron. We know that the electron is a charged particle. When this charged particle it vibrate, when charged particle vibrate, it emit electromagnetic wave. So here we write this incident ray, and this is the reflected ray. This incident ray is known as the primary source of X-ray. Primary source, that is the X-ray, and this reflected ray is the secondary source, that is the electron. When the X-ray is incident on this electron observe this X-ray and emit the reflected ray, which is reflected ray is source of the electron. This phenomena is known as the diffraction of X-ray by crystal. Now we discuss the Bragg's law. According to the Bragg law, if the X-ray is incident on any crystal plane, it make an angle theta. This angle theta is known as the Bragg angle. Then after reflection, we found this ray on the detector. The angle between the incident ray and the angle between the reflected ray is known as the diffracted angle. This is known by theta. This is the diffracted angle. Here the wave is incident on the crystal plane and it is reflected by the crystal plane. In crystal, the atoms are arranged in the parallel plane. Here we take the X-ray. X-ray is incident on the crystal in the form of the parallel beam. These are the parallel beam that are incident on the crystal. Let's suppose that the interplanar spacing is between them is the d. If the interplanar distance is d and X-ray is incident on this crystal by an angle theta, when the X-rays are reflected in the same way, they produce the interference pattern. This interference can be constructive or destructive interference. This constructive or destructive interference depend upon the path difference between these two parallel beams. We draw a perpendicular distance on the second beam by the first beam. When we draw the perpendicular distance, here draw the perpendicular from top to the lower point. This distance is known as the d. So this distance become the d sine theta, and this distance also become the d sine theta. If this angle is theta, by using the trigonometric function, we calculate the path difference between these two rays. So it means that the lower beam cover the extra distance. By trigonometry, we find that the distance is total is equal to d sine theta plus d sine theta, that is equal to 2d sine theta. This extra distance is covered by the lower beam as compared to the first beam. This is known as the path difference, that is equal to the 2d sine theta. We know that for constructive interference, that distance is equal to n lambda. So here we write 2d sine theta is equal to n lambda. This relation is known as the Bragg's law. Here d is the interplanar spacing, theta is the Bragg angle, lambda is the wavelength of X-ray, n is the order of diffraction. That is all about the Bragg law. Now we discuss what is the order of diffraction. Here we show the screen of detector. In the screen of detector, if we see the one peak, it means its order is diffraction is 1. If we see the two peaks, it means we have the order of diffraction is 2. If we see the three peaks on the screen, then it means we have the order of diffraction is 3. It means that the order of diffraction is order of diffraction increase. Order of diffraction n is increased when peaks increase. If the order of diffraction is increased and number of the peaks increase, if we continuously increasing the order of diffraction, then it means the peaks are compressed on the small area, so we cannot able to separate these peaks. Second, we write that Bragg diffraction relation, that is d2d sine theta is equal to n lambda. This relation is only applicable when X-ray reflected by two consecutive plane. Here we discuss the Bragg's conditions. We know that the Bragg formula, that is equal to 2d sine theta is equal to n lambda. So here we write the sine theta is equal to n lambda over 2d. If sine theta is equal to 1, then we get the maximum value. So here we write n lambda over 2d is less than or equal to 1. It means the wavelength lambda of X-ray should be less than the interplanar spacing. If we write 2d our lambda is equal to n from this formula, this n will give us the diffraction peak. If this relation is tell us this relation n is equal to 2d our lambda, that is give us diffraction peak. This relation tell us if we less wavelength, then increase diffraction peaks. That is all about the Bragg law conditions that we discuss. Also discuss the order of diffraction. If you like my video, please subscribe and share. Thank you so much. Allah Hafiz.